Hello friends, myself Prakash Kadve from KK Wak Polytechnic Nasik. We are studying centroid. Centroid means it is a geometrical center of any two-dimensional figure. Here some simple diagrams are shown: rectangle, isosceles triangle and a right angle triangle. Rectangle having length L, having width B. So geometrical center, if you see graphically, if I draw diagonals where these two diagonals intersect each other is called as a geometrical center of the rectangle. Naturally, it lies at the center. So, along length it will be at L by 2. Along height it will be at B by 2 from bottom as well as B by 2 from top. So, center of this rectangle or centroid of this rectangle lies at L by 2 from left edge as well as B by 2 from bottom. Similarly, if you go to this triangle, this side and this side of the triangle are equal. Now, centroid of this triangle, if you draw a center line from apex perpendicular to the base, you can see this diagram has symmetry on left hand side and right hand side. So naturally, centroid has to lie on this axis itself. So along x, if you see, the center of triangle will lie at base divided by 2, that is b by 2. But along y-axis, you have to find out using this equation. So centroid of a triangle lies at h by 3 from the base. So this is the base. If you draw a perpendicular to the base, this is called as height of triangle. And along this, if you measure h by 3, that is height divided by 3, this is called as centroid of a triangle. Next, right angle triangle. So these two sides are perpendicular to each other. So this angle is 90 degree. This I call it as base noted by B. This I call it as height H. So same equation lies here, lies at h by 3 from the base, and similarly along x-axis it will be b by 3 along x-axis measured from this vertical axis, that is y-axis. Thank you. Let us see another figures. This is a trapezium. Two sides are parallel to each other. A and B are parallel to each other, whereas the perpendicular distance between these two is called as height h. So centroid of this, if you see along base at b by 2 from this point, if I draw a vertical line, you can see this diagram is symmetrical about this vertical line. So naturally along x-axis the centroid lies at half of the base, that is b by 2. But along y-axis, so x bar is b by 2. But along y-axis means you have to find out this distance. What is this distance? So this distance is b plus 2a divided by b plus a multiplied by h by 3. The whole multiplied by h by 3. So this distance is always measured from this base. Here you have to use this equation carefully. When you are using this equation, you have to remember that b is longer side, a is shorter side, and h is height of the trapezium. Next diagram is semicircle. Along x-axis I am showing the base of the semicircle. So this is called as radius, or from here to here also it is d by 2 means it is radius. This is also radius. So along x-axis again from this point at a distance r or d by 2, if I draw a perpendicular line, you can see this figure is symmetrical on this side and similarly on this side. That means x bar is d by 2 from y-axis, but y bar means it is the distance measured from x-axis to this point, and it lies at 4r upon 3 pi. So this distance from base to the centroid is 4r divided by 3 pi, where r is radius of the semicircle. Given section is T section. You have to find out centroid, that is x bar and y bar for the given section. It is a combination of two rectangles. The first vertical portion is called as web or rib, and the second rectangle horizontal portion is called as flange. We'll use the usual equation x bar is equal to a1 x1 plus a2 x2, the whole divided by a1 plus a2. Similarly, y bar is equal to a1 y1 plus a2 y2, the whole divided by a1 plus a2, where a1 is area of first figure, a2 is area of second figure. So let us find out areas first. First figure is vertical portion having height 500 mm, width 20 mm. So A1 will be equals to 500 multiplied by 20. A2 is the second figure having width 400 mm and height 20 mm. So A2 will be equal to 400 by 20 mm. Then X1 and X2. X1 is the distance of center of the first rectangle measured from y-axis, or distance of centroid of first rectangle measured from y-axis in horizontal direction. So from the diagram it is quite clear, it will be lying at a center of 400 mm, that is 200 mm from y-axis. So x1 will be 200 mm. x2 is the distance of centroid of second figure from y-axis in horizontal direction. So total width of flange is 400 mm. It will lie at center of 400, that is 200 mm. So x2 is also equals to 200 mm. y1, it is distance of centroid of first rectangle measured from x-axis in vertical direction. So it is shown in diagram, that is from where to where the distance y1 is measured. Height of first rectangle is 500 mm. It will lie at the center of 500 mm, so that is 250 mm from x-axis. y2, it is the distance of centroid of second diagram measured from x-axis in vertical direction. So if you see, second diagram is lying at a distance of 500 mm from the x-axis. So this 500 plus 10 millimeters, total y2 will be equals to 510 millimeters. How this 10 comes? If you see the flange, the depth of the flange is 20 millimeter. So centroid of the flange in vertical direction will lie at 10 millimeters from top of the flange or 10 millimeter from bottom of the flange. We want distance from x-axis. So from x-axis it comes out to be 500 plus 10, that is 510 millimeters. Remaining thing is simple. You just put these values in the equations and you will get the answer. So accordingly you get x bar is equal to 200 mm and y bar is equal to, this is the second figure. Now here it is a combination of rectangle and a triangle. This triangle is particularly isosceles triangle having these two sides equal. This triangle is placed on the top of this rectangle. Here you have to find out x bar and y bar, that is centroid of this combined diagram. For simplicity, I am dividing this diagram into two figures. First is this rectangle and second is this triangle. Usual equation will be using x bar is equal to a1 x1 plus a2 x2 divided by a1 plus a2. Here y bar is equal to a1 y1 plus a2 y2 divided by a1 plus a2. You know the meanings of all the terminologies. So A1 area of first figure. Now this is my first figure having height of 60 centimeter and width of 30 centimeters. So area will be 60 by 30. A1 is 60 by 30 centimeter. A2 area of rectangle, you know, 1/2 base into height. So this is base. The vertical distance measured from the base to the apex is height and it is given as 40. So 1/2 into 30 into 40. So it comes out to be 600 centimeters square. Now x1, if you see, if I draw a vertical line through the center of this diagram, you can see there is a symmetry on left and right hand side. That means this diagram is symmetrical about vertical axis. So naturally its x bar will be at a half distance of the base, that is 30 divided by 2, it will be 15 centimeter. But let us, you can find it out again. So I will say x1 is the distance of centroid of the first rectangle. So measured in horizontal direction. So total width is 30 centimeter. Half of it will be 15 centimeter. X1 is 15 centimeter. X2, this is the triangle. It is symmetrical about vertical axis. So naturally x2 is also 30 divided by 2. So on this axis the centroid will lie. Now let us see y1 and y2. Y1 is distance of centroid of first rectangle measured from x-axis. So somewhere here it may lie. So total height is 60. So naturally y1 will lie at 60 divided by 2, that means 30 centimeters. Y2, it is the distance of centroid of triangle, but it is measured from x-axis. So I have to measure the 60 plus the distance of centroid of triangle. So the centroid of triangle lies at height divided by 3 from the base, h by 3, h is 40, so 40 by 3. So when I am measuring from x-axis, it is 60 plus 40 divided by 3. So you can see y2 is equal to 60 plus 40 divided by 3. That comes out to be 73.33. Now it's quite simple. You have got two equations. Just put these values in the equation. You'll get the final answer of this question. Thank you. This is unsymmetrical figure. It won't have symmetry about x or y axis. It is a combination of three rectangles. This is topmost is the first rectangle. Then from here to here this is second rectangle. And from here to here, that is extreme left to the right, it is third rectangle. You can have numbers in a reverse order, first, second or third, anyway that doesn't matter. Or even you can extend this line and you can extend this line, you can call the remaining portion as first, second, third. That is your freedom how to divide the rectangles. But here for convenience I divided by extending this horizontal line. So first complete horizontal portion of 800 by 40 mm is the first rectangle. Second 1520 by 40 mm is the second rectangle, and third one is 1200 by 40 mm, third rectangle. Your task is to find out centroid from extreme left edge and bottom of the diagram, that is x bar and y bar. Now since three figures are here, I will have a1 x1 plus a2 x2 plus a3 x3, the whole divided by a1 plus a2 plus a3. Similarly for y bar, it is a1 y1 plus a2 y2 plus a3 y3, and the whole divided by a1 plus a2 plus a3. Now let us see first of all a1, a2 and a3. a1 is area of first figure. Since I am calling this as first figure, area of this figure length multiplied by width. So 800 multiplied by 40, 32000 millimeter square. Second rectangle, height is 1520 and width is 40. So it will be 1520 multiplied by 40. Third rectangle, it is 1200 multiplied by 40. So it is A3 is 1200 multiplied by 40. Now let us see x1, x2 and x3. Now x1. Now I am assuming this as the y-axis, extreme left edge. So from this, I have to see where the centroid of this first rectangle lies. Since it is rectangle, it will be at the center. So total width of this rectangle is at 800 mm. Means along x-axis, its center will be 400 mm. Accordingly, x1 is 800 by 2, that is 400 mm. x2, this is the second rectangle. This is the width of second rectangle, 40 mm. I have to find out center from this vertical line. So naturally 40 divided by 2. So x2 will be 40 divided by 2. And x3 again from this vertical line where the center of this rectangle will lie. So it will lie at 1200 divided by 2 somewhere here. That is x3 is 1200 divided by 2. Then y1. This is again my first figure. So center of this first figure, if I see from top, the total depth is 40 mm. So since it is rectangle, it will be half of the 40. So from top it will be 20, but I want from this base or this bottom. So it will be this 40 plus 1520 plus 20 center of this. So it comes out to be 1560 plus 40 by 2, 1580. So this 40 plus 1520, it comes out to be 1560 plus up to center of this, that is 20 mm. Y2. Centroid of this second rectangle measured from this bottom. Now actually second rectangle starts from this line. This height is 1520. So it will lie at center of 1520. But I want from this line. So 40, this is 40 plus 1520 divided by 2. So it is 40 plus 1560 divided by 2. Sorry, 1520 divided by 2. And for the third figure, it is 40 divided by 2. That is 20 millimeters. It is quite simple. Put all these values in the diagram. You will get the correct answer for x bar and for y bar. Thank you. This is next problem. You have got combination of rectangle and semicircle. They are placed adjacent to each other. So I will call this semicircle as the first figure and rectangle as the second figure. You have to find out centroid of this whole diagram. Now if I draw a line here at the center parallel to x-axis like this, then you can see this figure is symmetrical about x-axis. Means the center of this figure will lie at half of this width. Now if I see here the radius given is 150 mm, means this will be 300 mm. That means y bar will be at 150 millimeter, that is at center of this height. But still we can calculate it. X bar, I have to measure it from this extreme left edge. From this point I have to measure the x bar distance in this direction, in x direction. So let us see again same equation. Since two figures are there, x bar is a1 x1 plus a2 x2 divided by a1 plus a2. Y bar is a1 y1 plus a2 y2 divided by a1 plus a2. Let us see a1. Area of semicircle. For the whole circle it is pi r square. For semicircle it will be half of that, that is pi r square by 2. That is equal to pi into 150 square divided by 2. x1. Now for x1, from this base it is 4r upon 3 pi. This distance is 4r upon 3 pi. I want from this end. So what I can do, 150 is this distance. 150 minus 4r upon 3 pi. So that is r minus 4r upon 3 pi. So 150 minus 4r upon 3 pi. I get x1. Then A2, area of second rectangle. It is a rectangle, it is quite simple. 700 multiplied by this, that is 300 mm. So 700 by 300 is your A2. X2. Now X2 I want from this point to the center of this second rectangle. Now if I consider only second rectangle, it starts from this point. Its total length is 700 mm. That means center will lie at 350 somewhere here. So 350 from this point, but I want total distance from this point. So 150 plus this 350. So it comes out to be 150 plus 350. That is your x2. So y1, as I told you, from this extreme base, center will lie at 150 mm. So y1 is 150. Again for this rectangle, the center will lie at total width of rectangle divided by 2. Width of rectangle is 300. So 300 divided by 2, it is 150 mm. So y2 is also 150 mm. You just put all these values in the equations for x bar and y bar. You get the answer for x bar and y bar. Thank you.